So this lesson is going to be on the sum of difference of two cubes. Now, before we jump into the sum and difference of two cubes, we are going to review the sum or difference of. We are going to do a little bit of review. All right. So we're going to go back and factor the difference of squares first, and then remember how to factor a little bit using the AC method or factor by grouping. And we're going to use that in our next lesson big time. So let's go ahead and start there first. So the first part of our lesson is reviewing. The most important rule of factoring is if there is a GCF, you do need to make sure you factor that out first, unless your terms are perfect squares or cubes. Then you might want to see how it pans out, and if in doubt, go back and factor out that GCF. Okay, a polynomial is completely factored when it's written in the product of two or more polynomials with integers as coefficients. And there's going to be some tricky times where we're going to be left with something that we can continue to factor further. So you just need to keep your eyes open for that. All right, so this is review. For before winter break, we talked about this right before winter break. And it's when we had to factor using conjugates, okay, of each other. So whenever you see perfect squares like 16 and 1, and x squared and y squared, we can continue to factor that, okay? But there's no middle term. And so what happened was the middle term canceled out. So in this case, the square root of 16 is going to give us 4x, and these square root of 1y squared is just going to end up giving us just y. So on the second binomial, this is going to end up being 4x and y. So those are conjugates of each other. We will be using that again in our last unit of the year with rational functions. All right, so that's as far as we can go. Nothing else can be factored out. So we're done. And that is a difference of squares. So we have a positive and a negative. Let's go ahead and take a look at the next example. Notice how we don't have perfect squares here. 5 is not a perfect square, but I did notice that I can take 405 and divide it out by 5 because it does end in a 5. So let's go ahead and see what our greatest common, it would be after we take out our greatest common factor, which in this case is going to give us 5, and they both share x squared. So that's going to go on the outside. So if I factor that out, I would be left with 1 minus 81 x squared. Now we can work with something because remember our squares are 1 squared equals 1, 2 squared equals 2, and so on. 4 squared is 16. What squared gives us 81, which would just be 9. So we're going to bring down our greatest common factor, which is 5x squared. And then when I factor, I have a difference of squares. We end up with 1 as our first term, and our second term is 9x. Because if I were to multiply this back out, I would end up with 1 times 1, which is 1, and then plus 9x minus 9x, and then negative 9x plus 9 multiplied together would give us negative 81 x squared. All right. So that is fully factored. I cannot factor that any further. We're going to go ahead and move on. Okay, want to see what you can do for these two problems. So go ahead and pause the video. Okay, and when you come back, these will be completely factored. Okay, so for the first example, notice how we can go ahead and divide out a greatest common factor, which is 3. Once we divide that out, we end up with a difference of squares type of problem that we can break apart. So that's what you had to do for the first example. Now for the second example, if you stopped right here, you would end up getting some points, but not all points, because remember what I said at the very beginning, there are some tricky polynomials that are going to pop up that you do need to continue to factor further. In this case, x minus 2 and x plus 2 would give us x squared minus 4. So you do need to go one step further. All right, so that's why we had to review difference of squares because they are going to pop up with our difference of cubes. Some are difference of cubes. Now with squares, it's always going to be the difference of squares. Okay, but with sum or difference of cubes, we could have it with a positive and a negative inside. We do need to go ahead and review factoring, just basic factoring. So let's go ahead and take a look at this first example. If you'd like to pause it and see if you get what I get and see if you remember what to do when we're factoring, go for it. Now would be a great time to pause. Alright, so looking at this, I noticed something about the three terms. These three terms are divisible by 2, they're all even, and there's an extra x value. So we can go ahead and divide out a 2x on the outside. So we're left with 3x minus 16x, whoops, I forgot the squared, minus 12. Alright, so on the inside we can go ahead and factor this a little bit further, but because a is not 1, I do have to do the AC method. So the AC method is going to be 3 times negative 12, which is going to give me negative 36. I need to see what are the factors of negative 36 that give us that middle term, negative 16. And that's ultimately what we're looking for. Now, I've already done the math. If you want to pause it and try to figure that out, go for it. But I figured it out to be 2 times negative 18. That would add up to give us our negative 16. So I'm going to split the middle, which it's been a while since you may have seen that, but it's going to help you out in our next lesson. Okay, so I'm going to go ahead and rewrite this. 2x is our greatest common factor, goes out in front, followed by 3x squared. We end up with negative 16x. We can break that apart as far as 2x minus 18x minus 12. All right. Next step is we're going to go ahead and factor by grouping. So we're going to go ahead and factor out of the first two terms. We can factor in x. We have 3x plus 2. Don't forget your greatest common factor. Yes, you can continue to use parentheses. And then I noticed that both of these terms are negative, so we can go ahead and factor out a negative 6. And what's left is going to end up giving us that 3x plus 2. Now, if you ended up with a negative 3x minus 2, you can continue to factor out a negative 1. All right, so greatest common factor still comes out in front. I can factor out a 3x. Whoa, that didn't look right. Plus 2. And an x minus 6. Now the very last step before you call this done is you need to go ahead and take a look to see if we can factor out anything from these two binomials. And in this case, we're done. There's nothing else to factor out. So let's go ahead and take a look at this next problem, and I'm going to go ahead and change the color that I'm working with. Alright, so for this one it just says factor completely. I love this because a is 1, so we can go ahead and just go straight to our binomials. Okay, so I notice that the factors of 12 that will add up to give me negative 7 would end up being negative 4 and negative 3, because when we multiply that, that gives us a positive 12, so that works out. And this one was actually easier than the example before. So we are done. And that is factored completely. Alright, so that's just kind of like a reminder of how to factor. You may need to use it when you're doing the sum or difference of two cubes. Alright, so let's go ahead and take a look at the lesson on sum or difference of two cubes. Okay, there is a video linked on the Google Slides that you can go ahead and see how these formulas work. And there's a great explanation for that. And if you really want to see how that works, please go ahead and click on that link and you can go ahead and see that. Otherwise, okay, I think I know what you're thinking. Maybe. And yes, you'll need to memorize these two formulas. But there are patterns with the signs that will make it a little easier for you to understand. So what we're going to do is, if it's a sum of two cubes, the formula, notice how it's plus. We started off with a plus sign, and then we end up with negative, and then another plus sign. But if it's a difference, it would be negative, and it starts off being negative. Now there's only one negative within the entire equation on this side of the equation, equal sign. So it's either going to be in front if it's a difference, or it's going to be in the middle. It's only in the middle if it's a sum of two cubes. All right, so let's go ahead and take a look at some example problems to kind of put this into context. So whenever we have cubes, that's also something we need to talk about. Okay, now squares are 1 squared, 2 squared, 3 squared. You know how those, and you've practiced with those very often. But when we're talking about cubes, that's 1 times 1 times 1, which is just 1. 2 times 2 times 2 is 8. 3 to the third power is 27. 4 to the third, 64. 5 to the third is 125. 6 to the third is 216. Okay, and so on. You can continue to go just so that you have kind of examples left to the side that you can match your problems up to. Like 7 to the third is 343, and you may see these values, and it'll help you out with these problems. So, let's take a look at the first example. The first example starts off with 2y cubed plus 128. Neither of those numbers are cubes. But remember the first rule in factoring? We need to see if there's a greatest common factor between those two. Greatest common factor, and in this case it's just going to be 2. So when I divide out a 2, we would be left with y to the third plus 128 divided by 3. Not by 3, I'm sorry, by 2. It's just going to give us 64. Alright, so now we have enough information we can go ahead and factor by a difference of cubes, or a sum of cubes, because we're left with a positive sign. So we can identify what is A and what is B for our equations. So A is going to end up just being y. 64, if we take the cube root of 64, that would just give us 4. So when we go ahead and factor this out, we're going to go ahead and start with just writing it down. So A plus B, A squared plus, so that's going to be A squared plus AB plus B squared. And at this point we just need to substitute in for A and B and see if anything else can be factored after that, and then you're done. So this is just going to end up being 2 times y plus 4 times A squared, which is y squared, plus 4 times y, which is 4y, and then b squared, which is 4 squared, which is 16. Now there's nothing else we can factor out of this polynomial, so you are completely finished on this problem. Alright, but you would want to check this first polynomial, y plus 4, to see if that can be factored further. And this right here, can you think of two factors that multiply to give you 16 but add up to give you 4? There aren't any, and I can tell you right now, all of your sum or difference of cube problems, this trinomial is not going to be factorable, so you stop right there. All right. Okay, so for this example, the first thing that we're going to do is just, because it's a difference of cubes, and I noticed that 216 and 343 are one of our cubes. We talked about that earlier, whereas 6 cubed is 216, 7 cubed is 343. We could go ahead and place it inside of our difference of cubes formula. Now, because we do have a subtraction sign, we will be using this pattern, where we start off with identifying what is A and what is B. So the cube root of 216 is going to give us 6, because 6 cubed is 216. 343 x cubed, if we take the cube root of that, that would just be 7x. Alright, so into our basic formula where we have A minus B times A squared minus not 2ab minus ab, that should be plus b squared. Alright, So we're going to go ahead and just substitute into our formula. So a is 6, so 6 minus 7x. And in the second set of parentheses, we're going to have 6 squared. 6 squared is just 36, plus 6 times 7, which gives us 42, x, plus b squared, which is 7 squared, which is 9x squared. All right, so there's nothing else we can divide out or factor out of these two, the binomial and the trinomial, so we would actually be done with this equation. This is as far as it can be factored. All right, so that's going to be a difference of squares because of the subtraction sign. Let's take a look at the next two examples. What I'd like you to do is you're going to go ahead and pause the video, and I want to see what you can do. So pause the video and then you can go ahead and replay it, or play it once you've completed these two problems on your own. And I'm going to go ahead and work it out, and we'll talk about it after we both press play. All right, welcome back. So on the first example, you'll notice that the a variable, or the a value, should be 2x squared, and then b, which would be the cube root of 125, which is just 5. So after setting that up, I noticed it's a difference of squares, or cubes, because of that negative sign right there, and we are missing some terms. All right. So I set up the equation, the basic equation, and we substitute a and b in. Last step is to take a look to see if there's anything that we can divide out of either the binomial or the trinomial, and in this case it's fully factored, so you're completely finished with this one. And it should just be 2x squared minus 5 times 4x to the 4th plus 10x squared plus 25. All right. So for the second example, I noticed that both terms have an extra x. So if they have an extra x variable, that's our GCF. We can go ahead and take that x out. And when we do that, we would end up just with x to the 6th minus 64. And there we have a difference of cubes, because x to the 6th, we can break that down to just being x squared to the 3rd power. And then 64, the cube root of 64 is just 4. So now what we can do is we can go ahead and substitute our a values in for x squared, and our b values are now 4. So after you substitute that, you would end up with this polynomial, but there's a difference of squares going on right here. So it's not fully factored. So if you stopped right here, it would be a half off point on a quiz. So make sure you can identify those difference of squares problems that will pop up when you are also doing difference of cubes. Alright, so when that happens, we do need to break that apart. And that would just end up being x times x minus 2 times x plus 2 times x to the 4th plus 4x to the 2nd plus 16. And this would give you a fully factored polynomial, which would allow you to see what's going on with the zeros very easily on the graph. Alright, that's it for this video. If you are struggling with this concept, please make sure you're asking for help. There is tutoring available for you. Please contact Ms. Young. And I hope you guys are doing well. Have a great day.